welcome back to our RGII webinar series. In this episode, we'd like to cover the topic of condense pipework. In particular, we'd like to cover the safe discharge of highly acidic condense to the wastewater system. Andrew, could you give us a bit of background on what we're finding in inspections and the topics we'd like to cover in this webinar?
I can, Keith. The condense system itself, Keith, and I'm sure the lads know this out there, it's an important part of the flue system on a high efficiency boiler. And the purpose of the condense, as we all know, is to discharge the condensate liquid, which is acidic, into a safe place, preferably the waste water system. There's a couple of scenarios around the way this can be done. I'll first talk about an internal connection. Basically, we all know that from these boilers, it's probably around a 22 mil pipe that comes off the condense, and the preferred option would be to bring that internally in the house, maybe in a kitchen, down into a kitchen sink, wastewater, and it's out. The second option there, where you can't achieve this, you can possibly bring this pipe out through the wall to the outside and discharge it into a wastewater drain. And the third scenario is you can actually bring this into a purpose-made soakaway. Now there's kits available for that at the moment. The other side of it is out on inspections we come across some problems. A lot of the problems could be fixed very, very easily. One of the problems is where some guys will bring the 22 mil externally.
Okay.
And they'll run it in 22 mil externally to a wastewater drain. Now there's a big issue with that because, like the recent cold spell we had, we were getting calls, boilers were breaking down, things like that, and the condense was freezing, backing up into the boiler, creates an unsafe situation in the boiler if the boiler fires. You get a high production of CO because you're interfering with the flame. So our recommendation would be is that you'd actually upsize the pipe internally, maybe up to 32 mil inch and a quarter waste. Take that out and then route that down to the wastewater drain. Now, try and avoid 90-degree bends if it's possible.
Yep.
Now, the other option is where we come across problems is where the pipe actually terminates out onto a footpath. Now, being of an acidic nature, it does create problems with paving stones, concrete. It'll affect all that stuff. It becomes a slip hazard in the winter. So
yep.
You get a customer out there, slips on this, breaks a hip, gets injured, there will be consequences. The other side of it is sometimes guys might fit a boiler in a position in the house and they're remote from a wastewater drain or gully. There is a condense pump available.
Okay. So
if the guys speak to the plumbing suppliers about this condense pump, this can be incorporated into underneath the boiler. It's a very small rubber tube, and you could literally take this tube anywhere in the house and connect it into the wastewater.
Okay, so if an RGI is in trouble with the location of the boiler, he can
get a condense pump. Yep, and they're widely available.
Okay. Is there anything else that an RGI should consider, Kevin, when thinking about how to route the condense to outdoors?
No, I think Andrew's covered most of the issues there, but it is extremely important that when they are going outside, which is probably about 50% of the times where they can't do it internally, that when they go outside with it, that they bring the inch and a quarter from the intern through the wall. A lot of install you'll see where they actually do use inch and a quarter, but it's outside, so they've 22 mil going into the equivalent of an inch and a quarter. So what we want to do is if you're going outside, extend the pipe through the wall in the larger diameter pipe. The other thing Andrew mentioned there, well, there is a high lot of compliance around this. We have had situations where people have used terminate into gutters, flower beds, cobble lock, and as Andrew mentioned there, the hazard that creates, and we've had some serious incidents around that. So it's important that people terminate, that they understand that this has to be taken away properly and into the
Wastewater system.
Yeah, absolutely. Yeah. So I think that's really it. Andrew, just to highlight again, the reducing the number of bends to 90 degrees to a minimum. If you have to use bends, use 45-degree bends. Make sure you have a proper fall on the on the condense, because it's not like a kind of a waste pipe where there's a good flow on the water. This thing is a kind of drip, and you have to try and get it away, and it needs as much assistance as it can. So.
And just to add there, Keith, with regards to the condense pipe itself, some guys may use plex pipe and brass fittings, which due to the acidic nature of the condense, it can actually rot the brass fittings, creating all kinds of problems. Where, I've come across the situations where a brass fitting has deteriorated. It stripped condense on the gas line. Gas line is copper, creates a bigger problem.
Okay.
And this is internal. So my recommendation to any of the guys out there, lads, if you're out there, use the proper condense pipe. Is 22 mil, and you can't go wrong.
Yeah. And just to finish on that, if you have to, as Andrew mentioned, if you have to use a soak well, there are kits available with most of the heating suppliers now, and they're extremely good way of using that type of an arrangement, rather than having to make one yourself, which you may not comply with all the bylaws around that issue.
Okay. So now we're going to take you to the hydrogen testing facility in Browns Barn, where Gas Networks Ireland are testing appliances using blended hydrogen and natural gas. Lar Burke, Residential Connections Manager with Gas Networks Ireland, invited me along to the Hydrogen Innovation Facility in Browns Barn. I asked him why Gas Networks Ireland built the facility.
Well, Keith, welcome to Gas Network's Hydrogen Innovation Centre. The gas network is the cornerstone of Ireland's energy system, powering 30% of Ireland's primary energy, 40% of its heat and 50% of its electricity generation. Natural gas emits significantly less CO2 emissions than, say, coal or oil, for example. So natural gas has been playing its part in reducing Ireland's energy emissions since the 1970s. But new technologies such as hydrogen will play its part in decarbonising Ireland's economy. And that's why we're here. We have standard gas boilers that will test the blend of hydrogen and gas, or with renewable gas, for example, that RGIs will be very familiar with. Standard gas boilers, standard gas appliances, and this is the future of what the gas network looks like. Hydrogen is a carbon-free gas that can be produced from renewable electricity and stored indefinitely, making it an attractive option to decarbonise energy systems. To ensure that hydrogen can be transported safely to homes and businesses around the country, Gas Networks Ireland recently opened a Hydrogen Innovation Centre in Dublin and is testing how best to introduce hydrogen for use in Irish homes, businesses and transport. Irish homes rely on the gas network to provide safe, reliable, flexible and affordable energy to meet their heating, cooking and power needs. By gradually replacing natural gas with renewable, carbon neutral and ultimately zero carbon gas such as biomethane, renewable gas and hydrogen, these homes and more will be powered by increasingly a cleaner energy future. It is exciting to think of a future where Irish homes could be consuming a net zero carbon gas, perhaps in conjunction with other renewable technologies such as photovoltaic panels, commonly known as PV panels. Panels based on the roof of each home generating renewable electricity. Gas Networks Ireland are ready to play our part in transitioning Ireland to a cleaner energy future.